So I expect you to ask now, well, how do I calculate this integral? Question. What is the integral of cosine x squared times x dx? Or what if I have an integral like this? What is the integral of x squared cosine x cubed dx? Or what if I have integral like this? The integral x cubed cosine x to the fourth plus, let us add a constant as well, plus 2 dx. Well, the only thing we learn is that the integral of cosine x dx is equal to sine x plus c. Or in more general form, we learn that the integral of cosine nx dx is equal to sine nx over n plus c. But we don't know if we multiply x by cosine of x squared, how do we calculate the integral? Well, in this section, we're going to define a new method, which we call substitution, to calculate the integral. So substitution is very similar to U substitution in taking the derivative, but now you're taking the integral. So substitution. Substitution method. In this method, you try to identify the term or the expression with the highest exponent. Identify the term or the expression with the highest exponent. Then that term or that expression is your u. So u of x is equal to that term or that expression with the highest exponent. Is the term or expression with the highest exponent. The next step, you need to find du, the derivative of u. Then find du, and then take the integral in terms of u. Okay, so this is our approach. This is what we're trying to do. So let's just write down u here. U is equal to the term or expression with the highest exponent. Then your job is to find du and take the integral with respect to u. Well, okay, let's apply this method, the substitution method, and calculate these integrals. So in each of these integrals, we need to identify the term with the highest exponent. Okay. In the first one, the term with highest exponent is x squared. So u is going to be x squared. In the next step, we need to find du, or the derivative of u. Du is equal to 2x dx. Okay, now what? Think about it this way. This integral is equal to the integral of cosine of x squared x times dx. Well, what do I have? I have my u, which is x squared. I have some part of du. Du is 2 times x dx. So x dx is du divided by 2. So x times dx, which I have here, is replaced by du divided by 2. Okay, so let's see. Let's now substitute everything, see what do we have. This guy is now equal to the integral of cosine u and x dx is du divided by 2. Well, what is the integral of cosine? The integral of cosine, I know it is equal to sine. It has 1 divided by 2, or a half. So a half goes in front of the integral. The integral of cosine is just sine. But what is u? U is x squared plus. One more time. In substitution method, we identify the term or the expression with the highest exponent. Then we need to find the derivative of that highest term or highest expression. Well, okay. So here we have u, which is equal to x squared. This is our u. U is equal to x squared. Du is equal to 2x dx. Remember that on the left-hand side, you have variable u, so it is going to be du. On the right-hand side, you have x squared. The derivative of x squared is 2x, but we are taking the derivative with respect to x. So we need dx as well. So take a look at the integral again. Here you have the integral of cosine of x squared, and this is x times dx, all right? It's just multiplication. You can just take x and write it in front of dx, x dx. I have 2x dx, so x dx is du divided by 2. Just divide everything by 2. Divide by 2. Du divided by 2 is x dx. Now just write everything in terms of u. It is equal to integral of cosine of u. This guy is du divided by 2. This is a half times du, so you can write it as a half. Integral of cosine of u du, which is a half sine of u plus c, but our original integral is in x, so we cannot keep u. We need to convert everything to x, so it is equal to a half sine x squared plus c. Very well. So what about this one here? X squared times cosine x cubed dx. Well, use substitution method, or substitution method in general says we need to find a term or expression with the highest exponent, which is x cubed. So u is equal to x cubed. Now, The next step is to take the derivative of both sides. The derivative of u is du, which is equal to the derivative of x cubed 3x squared dx. Well, let's take a look at our integral one more time. This guy can be written as the integral of cosine x cubed x squared dx. So I have some part of my du. I'm trying to simplify my integral. I have x squared dx. I don't have 3, but if I divide everything by 3, I get du divided by 3 equals to x squared times dx. So let's substitute everything. This is equal to the integral of cosine of x cubed, which is now u, cosine of u. And what is this guy? X squared dx is du divided by 3. Du divided by 3, it means that I have a third times the integral of cosine u du, which I already know what it is. The cosine of any variable, the integral of cosine of any variable is equal to sine. So this is equal to a third sine u plus c. But take a look at your original question. It's in terms of x, not in terms of u. So u is equal to x cubed. Just substitute this guy back. A third sine of x cubed plus c. So let us solve the last one. The last one was, I'm going to erase this. The integral of x cubed cosine of x to the 4th plus 2 dx. Okay, substitution method, the very first method that we learned is that, hey, find a term or expression with the highest exponent, which is x to the 4th plus 2. So this guy is going to be your u. U is x to the 4th plus 2. Now find the derivative. Du is equal to 4x to the 3rd. The derivative of 2 is equal to 0 dx. Okay, take a look at this. You have x cubed and dx in the integral. What's missing? 4 is missing, but we're not worried about that. It's just a number. It's a coefficient. It's a scalar. We can just divide everything by 4. So x cubed dx is du divided by 4. This integral can be written as the integral of cosine of u du over 4, which is a 4th integral of cosine of u du, which is equal to a 4th sine of u plus c. And since the original question was in x, you can just write this as a 4th sine of x to the 4th plus 2 plus c. And please note that if you have something like this, you cannot use substitution. If it was given to you, let me write it here, note. If you had something like the integral of x squared cosine of x to the 4th plus 2 dx, substitution doesn't work. Why is that? Because in this case, you identify the term or expression with the highest exponent and you say that, hey, I have my u equals to x to the 4th plus 2. So du is equal to 4x to the third dx. X to the third dx must be here, but you don't have x to the third, you have x squared. You cannot just simplify this and say that, hey, x squared dx is du divided by 4x. You're creating another x in the denominator. It's not working. So if you have something like this, another note for you. Good questions coming. So if you have x to the third cosine of x to the fourth plus 2x dx, and you say, hey, I identified the expression with the highest exponent, which is x to the fourth plus 2x. Now I'm going to take the derivative of both sides. du is 4x to the third plus 2 dx. Do you have 4x to the third plus 2? You only have x cubed. So substitution doesn't work. If you have 4x to the third plus 2, yes, of course, you can continue. Otherwise, if it's just x to the third, no. Well, give us more examples. We're interested in seeing more. Very well. Suppose I ask you to calculate this integral. Example. What is the integral of dx divided by square root of, oh, let me write down, x times dx divided by square root of 1 minus 4x squared. X times dx. Okay, perfect. So the very first method that we learned is substitution method. Substitution method says, hey, identify the term or expression with the highest exponent. The term or expression with highest exponent in this case is this term inside the radical. I don't care about the radical. I care about the term or expression with the highest exponent, which is 1 minus 4x squared. So this is my u. U is 1 minus 4x squared. So now we need to find du. The derivative of 1 is 0. Negative 4 times 2 times x dx. So du is equal to negative 8x dx. Do I have x dx? Yes. Do I have negative 8x dx? Unfortunately not, but this is just a scalar. This is just a number. I'm not really worried about this. This is x dx, which is equal to du divided by negative 8. Well, the rest is easy. Here I have the integral of my x dx is now du divided by negative 8. And here I have 1 divided by square root of u. So you can write this as 1 over square root of 1 minus 4x squared x dx, which is equal to the integral of 1 over square root of u. And here you have du divided by -8. So this is -1/8, the integral of du divided by square root of u. But this guy can be written as, remember that, recall. Here you have 1 divided by square root of u, which is 1 divided by u², which is equal to u², and the integral of u², du is equal to, this is just an exponent, we can add 1. So when you add 1, you get u², divided by 1/2, constant of integration. So this one can be written as -1/8. The integral of du divided by square root of u is the integral of u², which is u² divided by 1/2, square root of u divided by 1/2, which is -2/8, square root of u. Don't forget the constant of integration. So here you have -4 integral, the radical of 1 minus 4x² plus c. Well, how did we take the integral of tangent? What is the integral of tangent? Well, let's see. If somebody asks us, find the integral of tangent, what is our approach? Can we apply substitution method? But we don't have any term with the highest exponent. What do we do then? Suppose somebody asks us to find the integral of tangent x with respect to variable x. I'm saying that, okay, I'm going to try use substitution method, even though I don't have term or expression with the highest exponent. Let's see how it works. This is equal to the integral. Tangent is defined as sine divided by cosine. Why I'm trying to apply substitution method? Because I know that if I take cosine as u, du is negative sine dx. So we can apply substitution method for cases that is written in like quotient form. So note that. Sometimes we can apply the substitution method for quotient expressions. So when you're using quotient method, remember that. When you're using substitution method for quotient, remember that you're trying to simplify your integral. So when you try to simplify the integral, it means that, okay, here if I take u to be cosine, then du is equal to negative sine x dx. Sine x dx is here. Guys, you cannot use sine to be your u. Just let me write this down here. Note, if you take u to be sine x, then your du is going to be cosine x times dx. look at this quotient expression. In this quotient expression, cosine is on the denominator. It's not on the numerator. So you cannot use cosine x times dx. So that's why we cannot take u to be sine. So your u is your denominator. And now on the numerator, you have some part of negative sine x dx. But this is just equal to minus du sine x dx. So wherever you see sine x dx, you're going to substitute that by negative du. So this integral is now equal to the integral of minus du divided by u. You know how to take this integral? Of course. You know that the integral of dx divided by x is ln of absolute value of x plus c. But this is just a variable. I can switch that by theta, by y, by t, by anything that I like. It doesn't have to be x. So this is equal to minus ln of absolute value of u plus c, or minus ln of, what was u? Cosine x. ln of cosine x plus constant of integration. Remember now, when you have a negative sign in front of ln, it means that this negative sign can be converted into the exponent for the quantity that you have. So this guy can also be written as ln of absolute value of 1 divided by cosine x plus c. How? Take a look at this. Here you have ln of absolute value of cosine x raised to negative sign or negative 1 plus c. When you have negative exponent, it means that we can flip this and write it on the denominator. It is ln of absolute value of 1 over cosine of x plus c. But we know 1 over cosine is nothing but secant. So here you have ln of absolute value of secant of x plus c. Both of these are good, negative ln of cosine or just ln of secant of x plus c. Negative sign in front of the ln as the exponent for your quantity. Very well. So remember that in taking the integrals, we have plus the constant. So if you're multiplying your constant by a negative sign, you can use c sub 1, c sub 2, or you can just use a capital C, c sub 1, c sub 2. But eventually, whatever you're representing is plus a constant. This is by convention. Another example for you. Question says, evaluate this definite integral. The integral 0 to 4 of square root of, well, we have 2x plus 1 dx. Okay, let's try our best to apply what we just learned, substitution method. Substitution method says, hey, find the expression, find the term with the highest exponent. In our case here, in our example here, the expression that we have is inside the radical, and this is 2x plus 1. So this is going to be our u. So u is equal to 2x plus 1. du is 2 dx. Well, I have dx, I don't have u. I'm going to divide everything by 2, and du divided by 2 is equal to dx. Okay, now think about it this way. Here you have the integral of square root of u du divided by 2. My question for you is, should I keep the lower bound and upper bound as 0 and 4, or should I change it based on u? Is it still 0 and 4? Remember that your x is bounded between 0 and 4. Now you are switching to a new variable. It's not the same as x. It's different. It is u. So should I keep it as 0 and 4? Of course not. U is different from x. X is bounded between 0 and 4. What's the relation between x and u? U is 2 times x plus 1. So I'm going to multiply everything by 2. 2 times 0 less than equals to 2x. 2 times 4. So 2x is bounded between 0 and 8. But my u is 2x plus 1. So now I'm going to add 1 to everything. 1. So 2x plus 1 is bounded between 1 and 9. This guy is my u. So u is bounded between 1 and 9. I started from x bounded between 0 and 4 to u being bounded between 1 and 9. That makes sense. U is bounded between 1 and 9. It's not 0 and 4. We changed x into u. Okay. Now let's take the integral. This is the integral of u raised to a half. I'm going to write these 2 in front of the integral. du. This is our exponent, a half. So this is going to be a half times u raised to a half plus 1 divided by a half plus 1. And my u is bounded between 1 and 9. Okay, let's simplify this. Let's do a little bit of algebra. I have a half times u raised to 3 halves. 3 halves. U is bounded between 1 and 9. So here I can cancel out 2 and 2. So I get a third. And here I have 9 raised to 3 halves minus 1 raised to 3 halves. Okay. 27 minus 1. So I get 26 divided by 3. Very well. So let's take a look at this case. We have the integral, definite integral 1 to 2 dx divided by, well, 3 minus 5x squared, 3 minus 5, all raised to the second power. Okay. So let's see. Here you have a quotient expression. That's something on the numerator, something on the denominator. We have 2 approaches here. Let's see which one is working for us. We're going to use substitution. But for our substitution, we're going to try to see which one is working. You can say that, hey, u is equal to the whole denominator here, which is 3 minus 5x raised to the second power, or you can just take u to be equal to 3 minus 5x without the exponent. if u is equal to 3 minus 5x raised to the second power, by chain rule, du is equal to 2 times 3 minus 5x times negative 5 dx, which we don't have this guy on our numerator. Not on the numerator. So this method is not working. If you take u to be 3 minus 5x, then du is equal to minus 5 dx. Minus 5 dx. It's something that we can work with. In this case, dx is equal to du divided by minus 5. Okay. So for sure, we know that if we take the whole denominator to be u, it's not working for us. But if I just ignore this exponent here and take this term, 3 minus 5x, as my u, I can work it out. So here I get the integral 1 to 2. Here I have, let me see, let's just forget about this upper bound and lower bound. Eventually we're going to change those. Du divided by minus 5 over u squared. Well, this guy is equal to negative 1 over 5 integral du divided by u squared, which is something that I can work with. I already know how to take this integral. This is just a term raised to the second power. I can write it on top, and it's going to be negative 2. The only thing that worries me is that I need to find the boundaries for my u. Well, okay, x is bounded between 1 and 2. It's not that hard to find the boundary for 3 minus 5x. So you can do that, or you can keep taking the integral, writing everything in terms of x without changing the lower bound and upper bound, which are 1 and 2. So take a look at this. Here you have negative 1 over 5, and this guy can be written as u to negative 2 du, which is equal to, this guy is negative 2, so I'm going to add 1. I get negative 1. So I have 1 over 5 times 1 over u plus constant of integration. So if I just convert this back into x, I get 3 minus 5x. So it's going to be 1 over 5 times 3 minus 5x. My x is bounded between 1 and 2. I substitute 2, I substitute 1, then subtract the results and the outcomes. So this guy is equal to 1 over 5 times, here if I plug in 2, I get 3 minus 10, negative 7, minus 1 divided by, if I plug in 1 here, I get 5 times 3 minus 5, negative 2, 5 times negative 2. So you could just write a fifth in front of negative 1 over 7 plus a half, which is 5 divided by 14. So it's going to be 1 over 14.